Okay, example 3. So this figure is showing two coherent sources, S1 and S2. So the separation of S1 and S2 is given here, which is 1.2 millimeters. So let me write that. So that is small d kan. And then we have the distance of the source, the slit to the screen, that is capital D, that is 2.5 meter lah. So the frequency of the light is 5.77 times 10 to the power 14 hertz. So you have to calculate the wavelength of the light used. Remember, we can use the wave speed equation, which is c equal to delta f. Okay, so from here we can then get the wavelength. Calculate that, you will get 520 nanometer lah. Okay, that is the wavelength of the light used. And then for the second question, it asks us to calculate the separation between two consecutive bright fringe if the experiment is conducted in A, that is delta y equal to lambda d over small d. Okay, so the separation between two consecutive bright fringe and dark fringe is the one shown here lah. Okay, that is the equation. And then the between two consecutive bright fringes all there, not between bright and dark. So this substitute saja lah, then you will get 1.08 times 10 negative 3, because all of these are given, so we are just using this formula. And then question B, if the experiment is carried out in water, so now there's a medium, which is water, of refractive index 1.33. So we have to calculate the separation of two consecutive dark fringe pula. So that is delta x lambda d over small d. Okay. Oh, I think I should add untuk dark fringe juga kan? Boleh kali delta x begitu kan, tapi I think it's just gonna be delta y, not delta x. I'm not sure. I'll get back to you about that one lah. I'm not sure. And then we have this equation lah. We need the wavelength. So how do we calculate the wavelength if it is placed in water? So n is gonna be equal to the original wavelength divided by the medium punya wavelength lah, which is the new wavelength of light in water. So that is gonna be equal to lambda n lah. Okay, so you will get the new wavelength of light to be equal to 3.91 times 10 negative 7 meter. Okay, so substitute that into this formula and you should get 8.15 times 10 negative 4 meter. Okay, yeah, that is the solution for our example number 3.